Hello guys, welcome to the hands-on exercise of building a custom resource with Kubebuilder. This is the hands-on training part of the CRD video from the Kubernetes API series. In this lab, we're going to learn how to use Kubebuilder to create a custom resource and controller in Kubernetes. We'll build a simple task resource, a task operator to manage automated tasks in a cluster, and we explore concepts like CRD creation, desired state and observed state, spec and status, and validations around the CRDs. We will do the following. We will set up a Kubebuilder project. We will define a custom resource, add some validation rules to it, and install our CRD to the cluster. Let's get started. All right, let's start off by installing the tools that we need, Kubebuilder and Go. Let's start off by installing Kubebuilder. I'm going to download Kubebuilder from the Kubebuilder website and then move it to the bin directory. And we check if Kubebuilder is installed. So if I run this command, I see that I have Kubebuilder version 4.5.2 installed. Next, I installed the latest version of Go. Very similar. First download the Go binary and then put it in the bin directory. And also check the version of the Go that we have installed, 1.24. Now our environment is ready for Kubebuilder development. Let's move on. All right, let's start by creating a new Kubebuilder project for our task resource. We will create a task operator directory, cd into that directory, and run Kubebuilder init with a name for our Go module, the repository of our Go module, and a domain name for our API. So we're going to use example.com for the domain name and example.com/task operator for our repository. We'll give it some time. I'm going to pause the video. I'll let the process go through. Okay, now Kubebuilder has initiated a project. This has created a Go module under task operator with this domain. And we have a make file in here. As you can see, there's a make file in here. And if I now run make help, I see what options I have for interacting with my Kubebuilder project. These are the actions that basically help me with the SDLC. And let's just move on to the next part. All right, now we want to create a task resource or a task CRD. For that, we can create an API and pass in the flag resource true to tell Kubebuilder that we want to have a brand new custom resource for the API that is being created. We also want to listen to the changes on our resource by creating a controller. That's why we the create API command to also create a controller for us. So this generates a CRD scaffold in API/v1/task types.go and a controller in our controllers directory. So let's just run this command here and give it some time until the necessary Go modules and packages are downloaded. I'm going to pause the video. All right, it took a few minutes for this lab environment to take care of this task. Remember, this is a free instance with limited resources. Let's open up the directory that we generated so far and look at the generated files. So I'm gonna what I'm gonna do is that I'm gonna close this workspace entirely and open the task operator directory that we have created. So under API v1 and task types, we see the Go code that will be then translated to CRD, our CRD. This is our schema for our task API, and we see we have the spec and the status. And also under internal controller, we have a controller scaffold generated by default by Kubebuilder that listens to changes on our task resource. Let's move on to the next step. All right, now let's customize the task resource by editing the default spec and status. Before I do that, let's go ahead and install the Go syntax highlighting plugin on this browser to have some sort of highlighting on our Go code. All right, now let's run this command to do the updates inline on task types.go. We need to also get rid of all the unnecessary span tags that are injected by bad formatting. I just need to get rid of all of that. Okay, now it looks good and it is saved. And now let's look at the definition. We have a task struct that defines the schema of a tasks API. We have the spec and status. In the spec, we have a command and we have a schedule that basically is a cron format schedule. Basically, we define how often do we want our command to be executed, our task command. And the status is like, we want to know when was the last time our command was executed, our task was run successfully, and if it was successful or not. So now let's move on to the next step. All right, now we want to make some changes to our API schema by adding some validation. We use Kubebuilder marker for that. Let's add this validation for the scheduling on top of our spec. So we're going to just paste in this command. What does this command or this marker want or say? It basically says that the schedule should be immutable. So after we create our resource, if we try to change the schedule or making an update to our resource, there will be an error raised automatically by Kubernetes API server validation that basically says schedule is not mutable or is immutable. And let's add another rule and make sure our command follows the regex pattern that we have in here. Let's remove the span tag here. So that should be good. Here, what is worth mentioning is that self is referring to the current version of the resource and old self was the previous version. So when we perform an update, self is what comes with the update. So we check the schedule should be the same as the one in the previous version. Now we should have this sort of struct for our spec. Let's move on to the next step. So now we are in a good position to generate the CRD manifest based on our definitions. So let's just run this make manifest command and wait for it to go through. And then if you look at the config CRD bases, we see we have this automation example.com tasks, which is our API group and the name of our API, tasks API. And if you scroll down, we see we have, for example, the command that needs to follow this pattern and the X validations of Kubernetes, which basically is implementing the rule that we told Kubebuilder markers to implement for us. Schedule is immutable, and the rule is just checks the immutability of the schedule field. So now we have the CRD. Let's install it on our cluster. We can, of course, navigate to this config CRD bases directory and apply this YAML directly using kubectl, or we can do make install to install and the CRD. And if we have other markers in our code that basically generates other stuff we're going to get into later, other YAML files, they're going to be installed on our cluster with this make install command. But for now, let's just do make install to install our CRD. Make install needs to, for the first time, needs to download customize to make sort of some customization. If we have defined customizations in our for our CRD, now it will we will let it go through, and then we're gonna look at the CRD, see if we have our CRD installed on our cluster. I'm gonna pause the video. All right, now the make install is through. If you look at the logs, you just see that the task automation custom resource definition has been created by just looking at the logs, but to also verify that in this way we can get the CRDs and grep for task automation, and we see it is created. And if we look at, for example, this CRD of task automation and look at the status of it, we see that in the status our suggested name of tasks task.automation.example.com has been accepted, and there has been no conflicts, and the stored version or current version as we have it is v1. So and this is going to be the endpoint path of our API within the Kubernetes API machinery. So let's move on to the next step. So now we will have our CRD installed on our cluster. We can now define custom resources that follow the definition of our custom resource definition. Let's just run this command to create a sample task. We have a sample task created. And if we look at the sample task created, we have our sample task in here. If we describe it to look at the fields, we have the command, and we have the schedule, the cron expression, and the command that needs to be run on this cron interval. As you see, we have the spec set. We don't have any status. The status is empty because we haven't implemented the controller logic yet. So let's move on to the next part. All right, so we created our custom resource. What is currently missing is a controller. So we make sure we have everything, all the YAML files and manifests are generated and are matching our definitions in Go. We run these two commands to make sure that is the case, and we can start our controller by just simply doing make run, and this controller will watch for the task resources. For example, the simple task we created in the previous step. And as we talked about, the status is currently empty, but it is the job of the controller to update the status or the observed state of the word that this automation is trying to reconcile on, based on what happens during the workflow of our controller. So if we started, we can just simply see the basic logs that is currently in the task controller. So we should be able to see, I mean, currently we don't have any logs even in here. This is the placeholder for the controller logic that we need to implement. So everything, all the reconciliation logic needs to happen within this block. So let's move on to the next part. All right, now we see that our controller is running. Before we wrap up the lab, let's clean up the resources. For that, we can, if we want to stop the controller from running, we can just press Ctrl C. We can delete the task we created and verify that it is deleted. We don't have any tasks left in the default namespace. And we can also uninstall the CRD from the cluster by running make uninstall. And when we do that, we can check if it's gone. It is gone, CRD not found. And if we want, we can also go back one step and delete our operator directory. So let's move on to the next step. Great job. You've built a basic custom resource with Kubebuilder. If you're looking for resources to dive deeper into custom resource definitions API, definitely check out the Kubebuilder book, and the documentation of Kubernetes is definitely helpful on this. You can try enhancing this lab by building some logic to update the status field of your custom resource. And you can also try experimenting more with the validation markers and see what kind of effects they have on the CRD that is generated by Kubebuilder. If you are curious to learn more about Kubebuilder, please do check out the Kubebuilder crash course that I have created before on my YouTube channel. I'll also put the link in the description section of this one. I hope you liked the video. If you did, please give it a like and share it with your friends, or share your feedback with me in the comment section. Until the next videos, take care and see you soon. Bye.